Welcome to another day of Linux. Today we're going to be focusing on Linux permissions. Hope you're enjoying the course so far. As always, please leave a question in the comments section if you do have any questions, and I'll try to get back to you as soon as possible. So today we're going to be going into permissions for the Linux file system. We'll talk about something called GUID and SUID bits, also talk about how to manage system services, and then how to create system users on the account. So let's get into something called access controls. We're all familiar with the concept with Google Drive, and so if you create a file, if you upload something, you can actually assign different permissions to different people. So in order to access a file by default, you have to log into your Google account, and you have to sign in order to download that file. If you right-click on that file, you can actually assign different permissions to that file. So if you were working on a group project, you could give people read access or write access. So people could either modify it or only view it if you wanted to give them those permissions. So these are called access controls. People have certain permissions for certain resources based on what we give them. So on Linux, how does this apply to that? So each file on the Linux file system has certain privileges. It breaks down into three main parts here. So we've got the owner privileges, which is the creator of the file. We've also got group privileges, so the group the user is associated with. So let's say there was an engineering group, and this particular file had special permissions that said anyone in the engineering group can read this file. If you happen to be in the engineering group, you'll be able to read the file. If you're not, you'll be relying on these other permissions. Are you the owner of the file? If not, it'll check the group permissions as well. If not, what are the other privileges? So this means everyone else that doesn't fall into owner or group. Okay, so if you take a look at this slide here, we've got owner. There are three main permissions for each of these entities. So the owner will ask, can the owner read the file? Can the owner edit this file? And can the owner execute this file? Same thing for the group. Can members of the group read the file, edit, or execute? And can others read the file, edit the file, and execute the file? Now let's talk about this for just a second. What does reading a file mean? It means exactly what it sounds like. You're able to open the file, you can read the file, but you can't make any changes to it. What does editing the file mean? Or write permissions? We'll talk more about this in more detail. But when a user has edit or write permissions, they can change the file, they can modify it, they can delete it, they can add to it. Pretty much anything you could think of, you have full permissions to this file. So read permission lets the person view the file. Edit permissions or write permissions allows someone to modify it or delete it however they'd like. And then can the owner execute this file? If this is a program, can this user, owner, or group execute the file? So here are a couple commands we're going to be going over. We'll do some examples here. So if we use ls-l, we've talked about this before, this is going to show us all of the file permissions here. Also, if we use a program called chown, short for change owner, we're able to change the owner and group for certain files. And then chmod is actually going to be how we change permissions for the file. We'll get into more detail here. Okay, so the first thing I'm going to do here is I'm actually going to create a file. So I'm going to do touch my file. I created a file. Now if I do ls-l, my file, it's going to give the permissions for the file. We're going to go over this in a little bit, but left to right we're going to see read and write permissions, no execute, and we'll break down which parts are for the group, owner, and everyone else. But if you look here, the main part we're going to talk about for this moment right here is the owner of the file. So the owner is the first username you see here. The second one's going to be group. So the owner of the file is Cybertrack, and there's also a group on the system called Cybertrack. So if you are a member of the Cybertrack group, you will have whatever permissions the group settings have. Now let's say we wanted to give different permissions to this file. So because we own the file, we can actually modify it. So I want to do something like ch own So chown, change owner of this file. So my file. But before that, we also have to specify the new owner of the file. So let's say I wanted to change it to sysadmin and the group cybertrack. So the first part before the colon is going to specify the user, the new user, and then the group we can leave the same, or we can specify it again. So if I do enter, it says operation not permitted, so we might have to run this with sudo privileges. The reason being, we don't have write access to this user, so we need root privileges using sudo to do this. So I type in my password. And if I do ls-l again, look at my file, you'll notice the new owner of the file is now sysadmin, and that used to be cybertrack. Okay, so what is everything else here on this line? Let me just go over this quickly. So the first part here, the very first dash is going to tell you if this is, a file or a directory. So if I do ls-l, it shows me everything in the current directory. Everything in blue is a directory. Everything in white is going to be a file. Notice the blue files have a D in front of them. This means directory or folder. This just means a standard file. So there are 10 slots here, or 10 dashes, possible values. The first one tells you if it's a file or a directory. Now the next 3 are going to show you the owner's permissions. We'll get into what all these mean. The next 3 mean the group permissions. The next 3 are for everyone else. This is not super important, but it can be useful. It just tells you how many places this file or directory is linked to in the entire system. So if you made a shortcut somewhere for this directory in a different location on the file system, then it would be pointed somewhere else and we'd add another one, so then it'd be 3. We'll get into that later. Okay, and then the next one is the owner of the file. The next one is the group ownership of the file. So if you're a member of this group, you have whatever these permissions are. Remember, those are the group permissions, the middle 3. And then this shows you the file size, and then this shows you the last date or time it was modified, and then we've got the actual file name. Now, if you want to see the actual file size in human readable format, you can actually do -lh, and then it's going to give you some additional information. So we've got kilobytes, and if it was in megabytes, you'd see an M next to it, or G for gigabytes. Just makes it a little bit easier to read. So again, that was -h. Just append that on there. Okay, so we've gone over changing the ownership of the file. So if you look here, right, we talked about how the first dash means directory, D for directory, and then dash just indicates a file. If you saw L there, it would stand for a link. And the next 3 are going to stand for the owner's permission, so read, write, and execute. Right, so the read stands for, R stands for read, W for write, X for execute. And the next 3 is going to be for the group ownership. And then the last one is everybody else, so world permissions, or everybody else that doesn't fall into one of these categories. So how do we assign these different permissions? We're going to use a program called chmod. We'll get into that in just a second, but this concept might be a little bit confusing at first for a lot of people. I think the more you practice it, it's going to make more sense, and it'll be a little bit easier. So in each of these groups of 3 here, you've got R, W, and X. X is always going to have a value of 1. So you'll notice this first column has a value of 1. So that's where the X goes. The next column, or the W column, always has a value of 2. This is because of binary, right? It starts with 1, 2, 4, 8, 16, 32, 64. This is just how it is. We're not going to get into binary too much today, but if you're curious, this is where it stems from. So first column is 1, second column is always worth 2, the third column is always worth 4. So read always has a value of 4, write always has a value of 2, and execute always has a value of 1. So how do we assign different permissions to a user? Let's say we wanted a user to be able to read, write, and execute, like on the right part of the slide. So remember, read is worth 4, write is worth 2, x is worth 1, so 4 plus 2 plus 1 is equal to 7. So read, write, and execute permissions is 7. So if we assign 7 to the first part of it, that means the owner of the file, right, the creator or the owner of the file, can read the file, can modify or write or delete the file, that's what the W is, and they can execute the file. Now let's go to the middle part. So this example here, we've got an R and an X here. So the W is missing. What is an R worth? It's worth 4. X is worth 1, so this would be a value of 5. And if you go here on the left here where the little chart is, you'll be able to kind of look up on the table and see what the number correlation would be. I think the easiest way is to just always remember read is 4, write is 2, x is 1, and just add up what permissions you have. There will never be any overlap with any other permission type, so depending on what you see here, there's only one value possible. So a value of 0 means no permissions, 1 is x, 2 is w, 3 is 2 plus 1, right, write and x, 4 is read, so on and so on. So 5 is read and execute, 6 is read and write, 7 is read, write, execute. So each number is going to be correlated to a certain set of permissions. So the last one here, this means everybody else on the system. Someone that's not the owner of the file and also not a group member of the file, right? So in this example, we've got an R. That's a value of 4. They can read the file, but they cannot execute the file. So I'm actually going to list out a file, ls-l etc password, passwd. Now this is a very interesting file. It's one of the most important files as we talked about in one of our previous classes. So if we look here, the first dash, that just means it's a normal file. It's not a directory or a link. The first 3, read, write, and no execute, is the owner of the file. So this means root, which is the first part here, is the owner of the file. This means root can read and write to this file. Now what is the group? The group is root. And so if you are a member of the root group, you can read the file. Now, which permissions does it choose? It chooses the one with the highest level set of permissions. So if you are root, but you're also in the root group, right, it's going to default to the higher set of permissions. So in this case, root has read and write capabilities, and also anyone in the root group could read the file. But this one here, everyone not a member of the root group or root can read the file. So notice I'm using the user Cybertrack, so who am I, tells us who we are. And also if I type in ID, gives us a little bit more information. So I have a UID of over 1000. Remember, a UID of 0 means I'm root. So I'm not root, and I'm able to read the file. So what does reading the file mean? That means I can use cat to view the file. If I didn't have world readable permissions, right, if I scroll up just a little bit, so notice the permissions on this etc password file. If this R wasn't here, I wouldn't be able to read the file. So this means anyone on the file system or anybody can read this file. But what happens if I try to append to the file, actually change it? Okay, so if I try to echo hello world into the etc password file, it'll say permission denied. Why? Remember, I do not have write permissions to the file. I cannot modify the file. I can't edit it. I can't delete it. I can't change anything about it. I can read it. I can look at it all I want. I could even open it up with nano. I could do nano etc password. But if you look here, it says etc password is unwritable. So I'm just going to exit. And there we go. So hopefully that makes a little bit more sense about the permissions on the file. So right now I'm in my home directory. I just do ls, pwd shows me where I'm at. I'm in home Cybertrek. If I do ls-l, let's take a look at some of these files. So let's say I want to change the permissions on this file. So there are a couple things. If you don't own the file, you need root or sudo permissions. So I'm going to run sudo, and we're going to come back to this part. I'm going to put a blank line because we'll need to fix that in a second. This is what we'll put, where we will put certain permissions. And then we're going to put the name of the file. So let's say my file2.txt. This one right here. Let's change this so it's read, write, execute, read, and read. Now remember, read, write, and execute, 4 plus 2 plus 1 would be 7. So I'm going to come back here, and the first part's going to be 7, right? 4 plus 2 plus 1 is 7 for the owner of the file. So the owner can do everything, read, write, execute. For the group, we want read permission, so let's put 4, right? Read is worth 4, and we're not putting write, we're not putting execute, so we're just putting 4 there. And then the last part, we also want, let's actually do a different one here. Let's say everyone in the world, or everyone not a member of this group, or the owner, can execute the file. This is a very unusual permission. You would probably not see this ever. But this would be 1, because remember, 1, or execute has a value of 1. And then we need to run the actual program. So sudo chmod. This is just short for modify. So here's the syntax. We've got sudo, if we don't already own the file, and then chmod, the permissions we want to give it, and then the name of the file. And this is called octal notation. There's another notation I'm going to show you, but I think this is the easiest and probably the most standardized version. So if I do that, I do ls-l, my file2, look at this, the permissions have now changed. So here are the new permissions, and then file2 up here, these are the old permissions. So you'll notice read, write, and read. So this would have had permissions of 664. Now we've got permissions of 741. Very unusual permissions. So permissions that are very popular. 744, 755, 644, right? You're going to be seeing a lot of these. These ones are a lot more common than some of these other unusual ones. Okay, so we've learned how to change the permissions on a file. We've learned how to read different permissions. Let's go over one other notation on how to change permissions here. Okay, so if we want to change the permissions here, so sudo chmod of my file2.txt. In here, I'm going to start inserting a new notation. So this is the symbolic notation. So for user, you can put user equals read, write, execute, comma, put a space there, and I could put G for group equals read and write if I wanted to give it read and write permissions for the group. And we always put O for other. So let's say we want to give only read permissions to other. So what does this mean? User has read, write, and execute. Group has read and write. Other has only read access. So if I do enter, ls-l my file2, we've changed the permissions again. Read, write, execute, read, write, and other is just read. So depending on which one you're more comfortable with, you can use either one. You can use the octal notation, which is more standard. I think it's a little bit easier to write. Takes a little more practice. You have to think a little bit. After you realize R is always worth 4, W is worth 2, X is worth 1, really easy to do the math in your head and just put the number there. If you like it more visually, you can always do the symbolic notation. Okay, so now that we've talked about that, let's get into something called special bits. These are pretty interesting here. It's a topic that's a little bit hard to explain, but comes with practice. We're going to talk about more of this in the pen testing section. We're going to go over something called a SUID bit today. So a SUID bit, let me illustrate it with an example here. So we have a program called ping on the computer. We type in ping, we give it an IP address, and we're able to test the network connection to that location. In order to create these network packets, we actually have to run it at a root level. But it's a command that everyone needs to run, on a daily basis if you're using Linux just for network testing. But we don't want to give everyone just root privileges all the time. So instead of changing the sudoers file and saying, okay, sign this paper, whoever needs root access to ping, put it on here, and we'll add this program into the sudoers file. Instead, we can just add a special bit to this program saying anyone that runs this program is running it with root privileges. Now this sounds a little bit dangerous. It can be, but the programs that come default with the SUID bit are safe. Let me illustrate this a little bit more. So if we also want to allow all users to run the find command with the root privileges, we can enable the setting by adding the SUID bit on the program. So this means we don't need to use sudo or run it as root to run the find command, but it's going to run with root privileges or the ownership of the file owner. So the SUID bit, let's look for some programs with the SUID bit set on it. So let's come up here. I'm going to do find / perm permissions of 4000. I'll explain that in a little bit. Type f2 dev null. Now these are all the programs on the system with SUID bit set on them. And you'll notice ping is right here, so bin ping. So that's the location of it. Let's do ls-l bin ping. Let's see the permissions on it. Now in Ubuntu, it'll highlight it in red. This says this is a SUID bit, so anybody that runs this file is going to run it with the ownership, with the permissions of the owner of the file. So when I run ping, just as a standard Cybertruck user, so ping, I'm running a program there just to test my network connection to this IP address. I didn't have to run it with sudo though. I didn't have to append sudo ping 1111. I just ran ping, but it also ran with root privileges here. It makes it easy because it's one of those common programs that everyone needs. It requires root to run, but it's a safe program to run. And so by default, Linux has said, okay, we're going to allow every user to run the ping command, and it's going to run with root privileges. So we've got read, write, and this S here. So this is the SUID bit. This is in the ownership, or the owner trio right here. So read, write, and SUID. If you see a lowercase s here, this means the executable bit is also set. So it's read, write, execute, and SUID. If it's a capital S, it means it's read, write, no execute, and SUID. So in this case, it's a lowercase s, and this means this file is executable, and the owner can write it, the owner can read it, but anyone else that runs it is going to run it with this special permission. Okay, so what if we want to set the SUID bit on a program? So remember, we talked about different permissions. If we do chmod 744 myfile2, right, I just changed myfile2 again to 744, read, write, execute, read, read. Let's say I want to set the SUID bit on it for some reason. And so what I would do, this is just the syntax, so I do chmod 4 744. So I just add a 4 in the front to add the SUID bit. That's the next bit that we would set. I put file 2. If I do ls-l, you'll notice it's highlighted in red now. So my file 2, and it's got that little s in front of it. Now, why am I explaining this? SUID bits that come default on Linux are safe. They cannot be abused theoretically, right? If they are, they're generally patched in a future release of Ubuntu or Linux. This is something to always check for when you break onto a system. So you can check for different SUID bits on the system, and let's say you found a SUID bit on a certain program. So let's actually find a program. So which, let's do which less, user bin less. Now what if we wanted to set the SUID bit on this file? So I do ls-l user bin less. And this is actually pointing to bin less, so I'm actually going to do ls-l, right? L stands for link. It's like a shortcut from here to here. So ls-l bin less. So this file does not have the SUID bit, read, write, execute. And this means anyone can execute the file, but it's not running with root privileges. It's running with their user. If the SUID bit is sent, if the SUID bit is set, then it'll run with the ownership, or the owner of the file. So since we have a sudo privilege for Cybertrack, I'm going to run sudo, and for, let's see what permissions we've got. We've got 755, so I'm going to put 4755. I just had the 4 in front of it. And let's do bin less. I should also add in chmod. I do ls-l bin less, you'll notice it's red now. And you'll notice the little S there for SUID bit. Now what does this mean? Let's say we're a user. Let me switch to a different tab here. So I'm going to become a different user. Let's actually list out all the users in the home folder. So let's say I want to be, let's impersonate Jack. So I'm going to do sudo su Jack. So who am I? Jack. Now Jack should not have permissions to view the etc shadow file. Remember, we talked about how the etc shadow file contains all the password hashes. So I do ls-l etc shadow, and you'll notice the permissions on the etc shadow file. The owner is root, read, write, execute. Anyone in the shadow group can read the file, but they cannot write the file. Nobody else can read, write, or execute to the file. So let's take a look here. Jack. Is Jack root? No, so Jack cannot read, write, or execute. Is Jack a member of the shadow group? Let's type in groups. Jack is a member of Jack and sudo. So Jack is not a member of the shadow group, right? We just listed out the groups Jack is a member of. So Jack falls into this other category of everyone else. But you'll remember if we run, or we find the SUID bits, let's see what programs we have permissions to run as root. So if I do find dash permissions of 4000, and I'm looking for a type of file, and let's send all the errors to the trash can. It's like kind of like a black hole, dev null. So I'm looking at all these different files that we can run as SUID. And with some practice, or when you open up a first clean version of Linux, make a note of these. Get used to what you see here. So su, umount, ping, mount, password. This is the program that's used to change a password. Anyone should be able to change their password, but this program comes with Linux, and it also has the SUID bit. It requires root privileges to run, but we don't want to give everyone sudo or root privileges, so we just put the SUID bit on the password program. And you'll notice ping is there. We've got mount, so if we want to mount a USB drive or something, we could do that. And if we keep scrolling, you'll notice right here, this is the SUID bit that we just added. A less is a way to view a file. So this means anyone that runs the less program is going to be able to run it with root privileges. What does this mean? Let's do an example. So as the Jack user, who am I? I'm going to run, cat etc shadow. Remember, cat is just a way to view a file. Jack is not a member of the shadow group. Jack is not the root user. So Jack should not be able to view this file. Right? So if I do cat, it says permission denied. But what if I do less? Remember, less is running with the SUID bit, which means it's running with the permissions of root. Now I can view the shadow file. So that's why it's important to know what programs on your computer have the SUID bit set. So we should probably change that back. Not safe to have less as a program with the SUID bit set on it. Okay, so I actually am going to change that. So sudo chmod, and we can just do 755 bin less. And if we do ls-l bin less, we're right back to where we started. Now, how do you know which programs are dangerous if they have the SUID bit set? So what you'll do is you'll open up a browser and just go to this website, gtfobins.github.io. You can search for it, GTFO bins. If any of these programs are running with a SUID bit set, remember if we run that find -permissions 4000 command, and if we see any of these programs on that list, we can abuse that program. So if we scroll down here and we see, we've used sed before in the past, so sed. So if sed had the SUID bit set on it, what could we do? So we would run the program sed, and we would run this, and then this would allow us to get a root shell on it, assuming it was running this version. What if we had the VI program, or vim? So we could use vim to break out into a shell. Now what about the less program? Is it on this list here? So you'll see less here. We click on that, and you'll notice that if we run less etc profile, we view it, we can actually run an exclamation mark bin sh. All right, so just a little review here for the GTFO bins. If you find one of these programs here running that find command, it's potentially going to be really dangerous here. So make sure you run it with, search with shell, look through this list here, and if you see a program here, so let's say crash, click on shell, you would run this program, assuming it's running with the SUID bit, and you could get a root shell. So what can you do with root? You can abuse the system, you can change any file you want on the system. Okay, so now that we've talked about the SUID bit, let's talk about service accounts. So a service account is a process that runs on a computer, generally has a specific task. Generally things like file sharing, antivirus, backup programs, Wi-Fi, Bluetooth. These are things that don't have normal user accounts, but these are users that run in the background. So they're called service accounts. Right? So a server or service is just a computer that offers one or more services. A web server is a computer that offers a web service. Here's some commands that we're going to be going over pretty quick about managing services. Okay, so we're back to our terminal here. So first thing we can do here is run systemctl-t service all. What does this do? This shows us all the services that are running. Shows us the status, if it's active, is it running or dead, what's the name of it, a little description on what it is. So you can use the arrow key to go down. Now if I want to get the status of a specific service, so if I run sudo systemctl status, let's do smvd, it might not be running on your computer. Let's take a look here. On my Linux box, there's a service called smvd. It is currently running. Now if I want to stop it, I can run sudo systemctl systemctl stop smvd. Now I can run this command again, the status, and it's going to show as inactive. And then if I want to start it again, I can actually run start. Now what if I want to disable this service from starting up every time I boot up my system? I can just type in disable. So next time I reboot the system, this service will not start. If I want to enable the system, or enable this service on system boot up, I would just write enable. So I'm going to start up the service again, sudo systemctl start smbd. If I want to remove this program, I could always run sudo apt-get remove samba. Samba is the actual name of the program. The service that's running the program is called smbd. Little distinction there. So know the difference between the service and then the program name. Right, so you might be running Microsoft Word, but the process name might be like Word Doc Microsoft instead of Microsoft Word. Let's say we want to create a new service account. This is not something you'll be doing on a daily basis, but good to know. So if we want to create a user, right, we generally don't want to create a home folder and stuff like that, and we want to specify it's a system user. So if I run sudo adduser, I'm going to type in --system to specify this is a system user. Also, I want to specify I don't want to create a home folder, so no create home. Let's create service1 as the name of the account. So it's saying adding system user service, UID of 127, adding new user, not creating home directory. And you'll notice the UID is below 1,000. So anything over 1,000 is a standard user. Anyone with a UID below 1,000 is generally going to be a service account. So this can be used for backdooring systems. So you might want to create a service account instead of a standard user with a home folder. Okay, so if we want to remove the user, we can actually do sudo delete user, and then we can type in remove all files and then service1. Okay, so it says service1 user has been removed. Clear the screen there. So that's a little bit on how to create a service user if you wanted to run it, not as a normal user, but just as a service user. Let's do one more. So sudo adduser system no create home. Let's say service 77. Now if we let's do tail. So tail the etc password file. We'll be able to see our service user here. So service 7 will have special permissions to run different programs we assign to it. It has a UID of 127. Now it doesn't have a home folder, even though it says this is here, right? We specified no home directory, so home directory is not created. Also, you notice here it says no login. This means that we can't really log in as the user. It's not meant for a normal user interaction, so programs will run with this user. Okay, so let's delete the user again and type in 77 instead, and it'll delete our user here. Okay, so what have we covered today? Today we covered how to set different permissions on the Linux file system. We talked about SUID bits. Also, we talked about how to manage system services and then create system users. So I really hope you enjoyed today's class. Don't forget to subscribe. If you have any questions, put them in the comment section. And stay tuned, we're going to get into some more exciting stuff coming up.